All right, guys, are there any questions over any of the assignments so far? Any questions over any of the homework assignments? Okay, because y'all need to start getting those turned in. All right. Now, this is where we stopped yesterday. Yes? So, this is the problem we'll pick up with today. This is the one we'll look at next. We're not going to be doing all of them. We're going to do this one here and move on to the next one. So, whenever we look at these here, any of these, the main thing I would start off with is graphing. I'd graph it to start with. Because if we get any nice zeros, then we can use those. Because how many zeros are we looking for this here? We need at least 4. We need 4. There's going to be 4 solutions to this here, but I need at least 2. Because I need at least a number of solutions to take the degree from a degree 4 down to a degree 2. Okay, let's put that away. So we need to take it down from a degree 4 to a degree 2. So we need at least 2. So the first thing we can start off by doing is graphing it. So we'll want to type it into the graphing calculator. So if there's another function already there, you can clear it out, and then we'll type it in. So we'll have 6x to the 4th minus 11x cubed minus 16x squared plus 2x plus 4. And once we get it typed in, we can hit graph. And unfortunately, looking at this here, it doesn't intersect at any whole numbers. So looking for -1. It doesn't cross at -1, 1, 2, 3. It doesn't cross at any of these integer numbers. So what we can do is come back over here and find our rational zeros. Because we need 2 of these to be rational zeros, and 2 of them will. And to find the rational zeros, we find the factors of p and the factors of q, and do all the factors of p over the factors of q to find the rational zeros. Now the factors of p are constant term. P is the factors of the constant term. So this one here, we're looking for the factors of 4. So we'll have 1 and 4. And what other factors of 4 do we have? Well, 2 and 2. But again, just like when we list out the rational zeros, if there's one repeated, we don't have to repeat it. Since 2 times 2 is 4, 2 is repeated there, we only are going to list it once. We're not going to list it twice. Now we also have the factors of 6, which is going to be 1 and 6. But we also have 2 and 3. And at this point here, we can start finding our rational zeros. Well, the first value of q that we're going to divide all the values of p by is 1. Well, that really doesn't change anything, so we can really just list out plus or minus 1, plus or minus 2, and plus or minus 4, because when we divide each one of these by 1, we get the number back. Questions on this so far? Now again, we're using this to find the possible rational zeros, yes? Did it on the graph cross at 1, -1, 2, -2, or 4, -4? Did it cross at any of these points? No. So out of our possible solutions, we know that none of these are going to work. But we still need to list them out so we have them all to make sure we don't miss any of them. Now we can move on to when q is 2. So we can say 1 divided by 2 is plus or minus 1/2. Then we can do the next one. 2 divided by 2 is 1. We already have it. We don't have to list it. The next one, 4 divided by 2 is 2. We already have it. We don't have to list it again. Then we can move over to 3. So we can say plus or minus 1/3. Because 1 divided by 3 will give us 1/3. Then we'll move over to the next one, 2 divided by 3. plus or minus 2/3. And the last one, 4 divided by 3 is plus or minus 4/3. And lastly, we will look at is 6. So we'll have 1 divided by 6 is plus or minus 1/6. 2 divided by 6 is 2, almost 2, 1/3. I think you got ahead. 4 over 6 is 2/3. And 1/3 and 2/3 are already listed, so these are the only ones we have here. Now that we have these, we can reference them back to the graph to see if any of these match up. And we look at the graph, we do have one between 2 and 3, yes? So that's a little bit far out there on its own, so we can check with these here and see if any of these here have a value between 2 and 3. Well, 1/2 isn't between 2 and 3. 1/3, 2/3 aren't between 2 and 3. 4/3 is between 1 and 2. And 1/6 is between 0 and 1. Do we have any that are between 2 and 3? No. Which most likely means that's an irrational solution. If we have one, we actually have to have another. So that doesn't work. But we do have another positive value because it's between 0 and 1, yes? Is it closer to 0 or closer to 1? Or neither? That kind of looks in the dead center, doesn't it? Do we have one that's exactly between 0 and 1? We have a half, yes? So we could set up synthetic division and put 1/2 in the cubbyhole, and across the top we would have 6 for x to the 4th, negative 11 for x cubed, negative 16 for x squared, 2 for x, and 4 for our constant term. Now, in the graphing calculator, we went over this yesterday. Second trace. Second trace, the first option is value. We can plug a value in for x and it'll calculate it for us. So the value we're looking at, or the one we were going to try, was positive 1/2, yes? So if we hit enter, it tells us that when x is positive 1/2, the y value is, and if the y value is 0, it means it's a solution. So we know one of the solutions has to be 1/2, which means, different color, the remainder here is going to be 0. Because if the y value is 0, the remainder is 0 as well. Which also means that that's going to have to be negative 4. Because the only way I can add a number to 4 and get 0 is if the other number is negative 4. Now we can work our way through this here. So we can say 1/2 times 6, or half of 6. Negative 11 plus 3 is negative. Then we can do 1/2 of negative 8, or half of negative 8 is, we can add straight down. Negative 4 plus negative 16 is negative. Well, positive 1/2 times negative 20 is going to be negative, and it's going to be 10. Half of 20 is 10. And we could do these in a calculator. We can just have it 1/2 times 6, get 3. Negative 11 plus 3 is negative 8. Half times negative 8 is negative 4. Negative 16 plus negative 4 is negative 20. Multiply negative 20 by 1/2 and get negative 10. Negative 10 plus 2 is going to be negative 8. 1/2 times negative 8 is indeed negative 4. And 4 plus negative 4 is 0. Okay. Now, because we can definitely see that it does cross at 1/2, there's only going to be one solution there. There's only one value at that spot. So we need to look over at the other side, the negative side where it intersects or crosses. Well, where it hits the x-axis is very close to what? Negative 1, yes? So negative 2/3 could be it. It's close to negative 1. Well, negative 1/2 isn't that close to negative 1. Neither is negative 1/3 or negative 6. So that really leaves us with these two here, yes? Is with negative 4/3, well, that's too big. We're on the other side of negative 1, yes? So negative 2/3 is the other possible one. Well, we can go second trace value and say negative 2 divided by 3. And and we get a y value of 0. So all that's done is helped us, especially here, to guarantee that when we do the synthetic division with negative 2/3, we're going to get a remainder of 0, which actually means that this is going to be 8. So we can do negative 2/3 times 6. Well, here we can do 6 divided by 3, which is 2. 2 times negative 2 is negative 4. And then we can add straight down. Negative 8 plus negative 4 is, and we can do it again, negative 2/3 times negative 12. Negative times a negative is a positive. 12 divided by 3 is 4, times 2 is 8. Negative 20 plus 8 is, and as we saw already, negative 2/3 times negative 12 is positive 8. So we get this here. Any questions on this here? Now, even not knowing what the other two, we already know the other two are going to be irrational. If they weren't, I still could stop here because the degree of what I have is a degree 2. It's a quadratic. So what we can do at this point, try this again, one more time. Quadratic formula. Because if it works out that the two other solutions are integers, are nice numbers, they're just bigger than what the screen gave us, this here will simplify down to two numbers we can add and subtract and be done. Now over here, we'll plug our values back in. The 0 is the remainder. The first negative 12 is our constant term. The second negative 12 is term with x. And 6 is the term with x squared. So what we have left is 6x squared minus 12x minus 12 is equal to 0. Any questions on this so far? Is there a greatest common factor between these three terms? If there's one, go on and get rid of it, divide it out. And the reason we do this is it's going to make the numbers easier to work with. If there's a negative in front of x squared, divide everything by negative 1. Because it's going to change the denominator. If it was negative, instead of having negative or 2 times a negative number, having a negative number at the bottom of this fraction, it's going to be positive. It's going to make it easier to work with. Because if we do this here, 6x squared divided by 6 is x squared. 2x. Because plugging in 6, negative 12, and negative 12 is not as easy as plugging in 1, negative 2, and negative 2. Those are easier to work with. So what we can say here is x is equal to negative b. Well, b is negative 2. Plus or minus the square root of negative 2 squared minus 4. A, number in front of x squared is 1, times c, all over 2 times a. Questions on this here? Negative 2 is 2 on the denominator. In the denominator, 2 times 1 is 2. Now inside the radical, we could type all that into a calculator. So over here we can say second quit. So we can say parentheses negative 2 squared minus 4 times 1 times negative 2 and see what we get. We get 12. Now 12, there's a chance that we can take the square root of 12. And if we want to check that, we can just plug that into the TI-30XS, the yellow calculator is the other one. Take square root of 12, hit enter, see if it tells me something different than the square root of 12. And if we do, we get 2 square root of 3. both of these here divide by 2. Yeah, if they all are divisible by 2, we can take the 2 out. We can factor it out. Well, here 2 divided by 2 is 1. Here it's 1, so we're just left with square root of 3. So 2 of the solutions are 1 plus or minus the square root of 3. We also have 1/2 and negative 2/3. Any questions on any of this here? So on a whole, this isn't too bad. I mean, it could be worse. But for any of these here, we really can start off by graphing. If graphing doesn't give us, for like here, the degree is 4, 2 nice numbers, we can use the rational zeros to find 2, and then use the quadratic formula from there. Now this next one here is a degree 3, so how many solutions would we want to find? At least 1, but we need 3. There's going to be 3 solutions. We need to find at least 1, and then use the quadratic to find the other 2. Any questions on any of this here? The irrational conjugate theorem. Let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that the square root of b is real rational. If, really we're saying if x is equal to a plus the square root of b, then x is also equal to a minus the square root of b. If a plus b is a 0, then a minus b is a 0. This is the irrational conjugate. Just like with our complex conjugate, if a plus bi is a solution, then a minus bi is a solution. If we have one, we have to have the other. And that's all this is saying. So if x is equal to a plus the square root of b, then a also has to equal, x also has to equal a minus square root of b. Questions on this here? So this here is our next problem. Now it does have a good bit at the start. Write a polynomial function f of least degree that has rational coefficients and a leading coefficient of 1. I'll explain that more in detail once we get this towards the end. But the main thing we want to focus on is this here, that the zeros of this function are 3 and 2 plus the square root of 5. These here are our 2 solutions. What this is saying is that x is equal to 3 and that x is equal to 2 plus the square root of 5. When it says it's a 0, it's a solution. It's saying that for the given polynomial function, we have that x is equal to 3 and x is equal to 2 plus the square root of 5.
It's perfect. I will send Mr. Thomas to get it. Is there a good time where he's not going to interrupt you?
7th hour.
Okay. Thank you.
You're welcome. So any questions on how we've started this so far? Now, according to the irrational conjugate theorem, if x is equal to 2 plus the square root of 5, x is also going to equal to minus the square root of 5. Because if we have the positive radical, we also have the negative radical. Because we're only really changing the sign in front of the radical. Now, on the first set that we did for this section where we talked about factoring, solving by factoring, we took the polynomial equation, we factored out a variable, and then factored where we got multiple things multiplied together, yes? Equals 0. According to zero product property, if we have more than one thing multiplied together to equal 0, one of them must be 0. We split them up and solved, yes? This year we're going backwards. So the first thing we want to do is to get all of these here equal to 0. We want to get all these here equal to 0 first. That's the first step. So if we look at this one here, x equals 3, we're going to minus 3. So we have x minus 3 is equal to 0. We want to do the same for the other 2 here. So the first thing I can do here is subtract 2. 2 minus 2 is 0, so here we have x minus 2 is equal to the square root of 5. Now it's still not equal to 0, so we will subtract the square root of 5 from both sides, telling us that x minus 2 minus the square root of 5 is equal to 0. So now it is. And we just need to do this one more time. We need to do it with this one here. So the first thing, as the last one, we'll minus 2 from both sides, telling us x minus 2 is equal to negative square root of 5. Now this time here, we're not going to subtract. We're going to add the square root of 5 to both sides, telling us that x minus 2 plus the square root of 5 is equal to 0. Any questions on this so far? So really all we did was set the solutions, what they told the zeros were, equal to x. And we just moved it all to the other side and got them all equal to 0, yes? Now, we're going to multiply them together. This is really just the ones that we did with factoring, just backwards. We're starting out with the solutions and going back to what we started with. Any questions on this so far? When you multiply these together, always multiply the conjugates together first. Always do the conjugates together first. Because if you remember multiplying, let's see here, 4 minus 7i and 4 plus 7i. When we multiplied these together, all the i's simplified out, yes? So that also means when we multiply these two, x minus 2 minus the square root of 5 and x minus 2 plus the square root of 5, all those radicals will simplify out. That's why we're going to multiply them first. So if we multiply these together, well, we'll have x minus 3. So we'll do x times x, which is x squared. X times negative 2 is negative 2x. And x times the square root of 5 is going to be plus x square root of 5. Then we can move on to negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 2 is going to be plus 4. And negative 2 times the square root of 5 is negative 2 square root of 5. Yes, sir. You have your pass. Saturday school. Then we'll do it with the square root of 5. You want to go to the bathroom, or let's not do Saturday, let's say detention, lunch detention, which you want. Okay? So we'll multiply the last one here with the square root of negative square root of 5. Well, negative square root of 5 times x is negative x square root of 5. Negative square root of 5 times negative 2. The negative and negative make a plus. And then we have 2 square root of 5. And lastly, negative square root of 5 times square root of 5. Well, the positive times a negative is a negative. And the square root of 5 times the square root of 5 is 1. 5. Because we're really saying either the square root of 5 squared, because it's times itself, square root and square cancel. Or we can say square root of 5 times 5. 5 times 5 is 25. Square root of 25 is 5. Now we look at this here, because I was saying that it looks that all the radicals were going to cancel out, but it doesn't look like it. It looks like it just got bigger, yes? Now, let's combine like terms. So the first one we have is x squared. Are there any others with x squared? No, so we just have x squared. Now, we'll skip over to this one here, x square root of 5. Is there another one with x square root of 5? It's negative. So we have x squared of 5 minus x squared of 5 is 0. Here we have negative 2 square root of 5. Here we have plus 2 square root of 5. Well, those are, do we have any radicals left? No, they all simplified out. Now when we combine the rest of the terms, well, negative 2x minus 2x is negative 4x. And lastly, 4 minus 5 is so when we multiply the irrational conjugates together, all of the radicals will go away. And lastly, we multiply these here. So x times x squared is x cubed. X times negative 4x is negative 4x squared. And x times negative 1 is negative x. Then we'll do it with negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x is plus 12x. And negative 3 times negative 1 is plus 3. Last but not least, we'll combine like terms. So we'll have x cubed. Negative 4x squared minus 3x squared is negative 7x squared. Negative x plus 12x is plus 11x. And then we have plus 3 is equal to 0. And that's it. That's all we have to do for this here. Any questions on this here? Now again, at the top it said least degree. The least degree, all it's saying is any of these solutions, like x minus 3, is only going to appear once. Each of the solutions will only appear once. They're not going to appear multiple times. That's what they're talking about least degree. When they say leading coefficient of 0, or leading coefficient of 1, we're not going to be multiplying the whole thing by a set number, because if I multiplied the whole thing by 2, it doesn't change the solutions. These two are going to have the same solutions. They're just going to look different. We want a leading coefficient of 1. So we're simplifying it to be just that equation there. Any questions over any of this here? And that is it. That is all we're doing for today.